Hi, so we are now in week 4, and this week is all about multiple inheritance. So, just a brief reminder of what we have already done. So, one of the things that you already know is that whenever there is a case of inheritance, the private members are not inherited. That is something that we already know, right? And for any particular method that you may feel that it might be re-implemented or required to be re-implemented in any of the derived class, such a method could also be declared as virtual, right? So whenever you declare a method as virtual, the derived classes, it is expected that the derived classes may provide a different implementation for this function. If you make a function as pure virtual function, then the derived classes must provide a definition for it. So this is the difference. If it is just virtual, the derived classes may provide a definition for it or may not, and of course a definition is also required in the base class. But if it is pure virtual, it means that you have not provided any definition in the base class, and now the derived classes are forced to provide a definition for these methods. Now we also know that there can be a hierarchy of classes, right? So basically one class, which it could be a base class for another class, and at the same time it is also deriving from another base class, right? So that is the kind of scenario we saw. So for example, we had seen this inheritance hierarchy, and here you can see that this pizza class is essentially the derived class with respect to wheat based dishes, and then it is a base class for this onion and tomato pizza classes. So this much we already know. Now this is something that is very important, right? Whenever we talked about inheritance, we talked about this whole idea of specialization and generalization relationships, right? So whenever I say pizza is a derived class of wheat based dish, what I really mean to say is that pizza is a type of wheat based dish in the real world, and at the same time I can say that onion and tomato pizza are basically a type of pizza, right? So pizza can be of different types, this or this. So you can see that there is a generalization specialization relationship in this hierarchy. As you move from top to bottom, things get more and more specialized, and as you move from bottom to top, they get more and more generalized. Now in these hierarchies that we have seen till now, you would have seen that basically for every class there was at max one base class, right? At max, as in it is possible not to have any base class, but in case you wanted to have any kind of inheritance, then you basically inherited from one particular class. So this kind of inheritance is also known as single inheritance, where a particular class only has at max one base class from which it is inheriting. Now another type of inheritance that you may see some places is known as multiple inheritance. In multiple inheritance, a particular derived class can have more than one base classes as well, right? So here's a real world example. You know that Domino's offers something like this. They call it burger pizza. I've never tried it and I don't want to, but yeah, this is what they basically offer you. So in some ways, if you want to represent this in terms of our class hierarchies, you can say that burger pizza is a class which inherits from both pizza as well as burger. So now burger pizza has two base classes, okay, pizza as well as burger. Now in general, if we talk about is multiple inheritance, it is actually a controversial topic. The reason I say it is controversial is that there are many people, including me, who feels that this whole idea of inheriting a particular object from multiple classes makes it really difficult to analyze them, right? Analyze as in that whole generalization specialization things that we've been talking about, right? That as you move from bottom to top, things generalize. As you move from top to bottom, things specialize. It becomes a little difficult to imagine this, right? Because there is, for example, a type of pizza which is also a type of burger. It becomes difficult to understand it. But as I just showed you from the real world, there might be certain cases where that you have no other option but to inherit from two different types of classes, right? But yeah, I mean, there are other ways to represent this, but at least in this semester, we are open to the idea of multiple inheritance. We say, multiple inheritance could be used in the design as well as coding part. So here we are going to have a look at how multiple inheritance can be used. Of course, there are certain, as I said, and because it is controversial, because there are certain problems associated with it. So we'll also have a look at one specific problem that you will find in case of multiple inheritance. And this problem, you can just try to imagine it, is that let us say there is a property or a behavior which is common to both classes, and it might not even mean the same. When I say common to both classes, I just mean that the way they are identified, their names for example, they are exactly the same. Now when you inherit these members from these two base classes into one derived class, what really happens, whether you inherit both of these members, whether you just inherit any one of them, whether you inherit both of them, this is something that is a problem, right? Whenever you think about multiple inheritance, this is an issue, right? When you have the same behavior in two or more base classes, what really happens to this behavior or this property inside the derived class? So let us just have a look at this one. Let us say you have a field called type in pizza, which could be, let us say, small, regular, or large. Or and at the same time, you also have the same field type in the class burger, where the possibilities are small, medium, and large. Now, when burger pizza inherits both these classes, and assuming that this type field is inheritable. When I say inheritable, it means that it is either in the public or in the protected section of these two classes. If it is private, of course, then it doesn't matter, right? Because then it cannot be inherited. But provided that it is inheritable and it is going to land up in burger pizza, what really happens to type here? That is the problem that I'm talking about, right? And in some cases, of course, in whether your language in which you are building your system supports multiple inheritance or not, that is one issue. If it does support multiple inheritance, how exactly is this problem solved? That is left to the language's implementation, right? So different languages might have different ways to deal with this. But there is one peculiar case in which this problem becomes even more interesting, right? So let us just try to imagine this problem is known as the diamond problem. So you can see that one possible way to solve this multiple members with same name problem is to simply rename them, right? So for example, if in these two classes I change the type variable in pizza to p underscore type and the type variable in burger to b underscore type, then the confusion is solved, right? Now burger pizza can inherit both of them. It can either use them or not, it doesn't matter. But there is no problem with the implementation, right? We have two distinct fields which are being inherited by burger pizza, and we can even have another type field added to burger pizza itself. But we don't have any issues right now. We can basically say that we have resolved this conflict. But let us say there is this hierarchy is just not one level, but let us say two levels. Okay, so what I'm trying to say is, assume that pizza and burger, they both have this wheat based dish as their base class, right? So I mean, burger also uses these buns, and these buns are also made through wheat. So let's just say that I have a particular case where wheat based dish is let us say the ultimate base class, from where there are two derived classes, pizza and burger. And then this burger pizza is then inheriting these two, okay, as the base classes. So essentially what you see is something like this, okay. Something on the top, two classes in the middle, and then one more at the bottom. So it looks, something similar to a diamond. That is why it is called as a diamond problem. So what really happens is, in such a case, the members, all the inheritable members from wheat based dish will become a part of pizza and burger as well, right? They'll come to pizza and burger. And assuming that pizza and burger are not putting it in their private sections, so they are still inheritable. When burger pizza inherits from pizza and burger, these fields from wheat based dish will also land up in the in the burger pizza class. So now here you don't even have that rename option, right? Because these members are not really the part of pizza and burger, they are coming from the base class. So you cannot really differentiate, you cannot rename them, for example, in pizza and burger. So with the same exact name, they'll come up and land in the burger pizza class. This is known as the diamond problem, and one of the major reasons to avoid providing the options of multiple inheritance to developers and designers is to avoid this diamond problem, because once a diamond problem is occurring in your design, it becomes slightly difficult, slightly tricky to how to to solve it. In C++, the implementation actually maintains a single copy of such fields. It is possible to do so, that you tell the implementation that please do not make multiple copies of the fields from, let us say, wheat based dish. There is a way to do that, but you can also use another operator called the scope resolution operator, and with the help of that, even if you don't want, if you do want multiple copies of these fields, you can still have it, and you'll have to use the scope resolution operator. We'll see how to do that in C++ in the second part of this lecture. Okay, there is some homework, please have a look at it. Thank you.